But the other part of your homework is one question, but there's like different parts, like A, B, C, D, E, F. Where they ask you to, given a weird graph like this, to do the transformation. So I printed these out for you so that you would have the graphs already and you would have to do them all. But this is on your unit test. Like, they give you a problem and they ask you to do this a few times. So I want to make sure that we point it out. On your homework today, they actually write the points on here, so they kind of point out what points you should be using. And I just was doing this with my mouse, and I didn't want to, like, handwrite the points. But we could go through and we could put our ordered pairs on here, right? Maybe. Your graph shows up way better than mine does. 1, 2, 3, 4. Is that -4, -2? And guess which one you're doing for homework? And this is 0, 2. And this is 2, 2. And this is 4, 0. Yeah? So maybe I'm going to double page this so I can look at this and do this at the same time. What if they asked you to take that function and do +3? What does that mean is happening to your function? What transformation, Bryce? It goes up 3. So I want you to take this graph, and here's the key idea. The points that they give you, if you know that this means up 3, can you just take all these points and put them up 3 and then have the same graph, only it moved up 3? It's not so bad, right? But I just want to make sure we did an example of that. So I was at -4, -2. I'm just going to go up 1, 2, 3. So that's going to be my new dot. The original point was at 0, 2. I'm going to go up 1, 2, 3. At 2, 2, I'm going to go up 3. And at 4, 0, I'm going to go up 3. So I get the same shape. I just moved it over. And the idea is, if you know what the transformation means, then you can do that problem. So what about B? If I asked you to do f of x plus 2 on the inside, what does that mean to do? Yeah, plus is the opposite way, right? So it's not going right 2, it's actually going back. So this would be going back left 2. So that means we need to take each one of these points, and we need to shift it over 2. So I guess these aren't so bad to do. The annoying part is just you have to make the graph every time, which is why I printed the graphs off for you, so you didn't cry too much. If I'm not nice every day. Because most of the time you're not graphing this much. So I went back 2 on that one. At 0, 2, I'm going to go back 2. At 2, 2, I'm going to go back 2. And at 4, 0, I'm going to go back 2. And again, I got the same shape. I just shifted it over. Who has a question about that? It is. This is the same problem over and over again, just different stuff, right? What? Yeah. Yes. So there's only one of those you have to do. So that's good. Let's see if I can make this stay here. How about that fanciness? Because it pins that one there and it keeps it there. So then I can switch the pages but keep that first page. It's like I thumbtack that one down. What does a negative out front do to your function? It's going to flip it, but which way is it going to flip it? Is it going to flip it over the x-axis or flip it over the y-axis? I think the y's are going to change value, not the x's. So if y's change values, it's going to be the x-axis. Yeah? It should be flipping over the x-axis. It flips over the y-axis if the negative's on the inside. So this is where it does actually kind of check to see if you know the transformation. You can look at your notes back to do that today, or in your book very, very nicely on page 251, there's this big giant blue box, and it tells you all the rules, and it even says, what do you do? So for this negative f of x, it says multiply y by -1, or change the y values. So everything is going to flip, right? So this -4, -2 is now actually going to be -4, +2. And 0, 2 is going to flip down to the bottom and become 0, -2. That one's going to flip down. What about 4, 0? Does it move? You can't flip it when it's already on there. So it's going to stay right there. So now I think it's going to kind of look like that. Okay, it flipped over.
I don't know that song. I don't know what that song is.
What about on D? What's happening on D?
Down to left one.
Yeah, it's two things are happening. This means it's going down two. And remember, inside means left or right, and it's the opposite way you think. So it's down two and left one. So for every point, you need to go left one, down two, or down two, left one. Doesn't matter which order you do that in. So let's see if we can agree on that. So I like to just start at my original point, and I'm going to go down two, back one. 0, 2, down 2, back 1, down 2, back 1, down 2, back 1. My C's not very good. Questions about that part? Like the reflections over, like, isn't so bad. The tricky part, I think, sometimes is the stretch and the compression, which are my last two I wanted to just go over with you. And then that's really all my notes today. Really. Like the next slide is your homework. Well, because I didn't have this on yesterday, and it was on your unit test, and I wanted to make sure I did it. And I knew it was Friday, and people are going to be freaking out about football. And
Did you have this up on our email?
I think so. Did you not?
Because I clicked on it because I thought like I was just clicking and the thing that popped up yesterday that go over it.
Oh, and it was this?
Yeah, and I was like,
Maybe I
it's not what we did.
put the wrong notes up.
I think you did because this isn't even what it was. It was something like log X A.
Oh, you know what? I put pre-calculus notes up then on yours because in pre-calculus we're doing the same. Like we're on 3.5 in pre-calculus. So when I copy the notes, I bet I put pre-calculus notes. I'll try to go back in.
It was all like log.
Yeah, sorry about that. I'll try to fix it. I bet Taylor's wondering what the heck's going on. Sorry, Taylor. I am recording. I think she heard it. So on this one, then there's a number multiplied out front. That means it's a vertical stretch by a factor of 2. So vertical stretch. I don't know if that's spelled right. And the book here says to do that, because we're stretching it vertically, what you're going to do is you're going to multiply every y value by whatever that number is. So since there's a 2 in front, it's like we're doubling the y values. It's kind of tricky without an equation sometimes. The x values are going to stay the same spot because you still pick the same x values, but it's just doubling the y values. So what does that make -4, -2 become? Yeah, we just doubled this number, so that becomes -4. So it now becomes -4, -4. So this one's going to change our shape. It should stretch it out. So I'm going to go through and double all of these numbers. So maybe you want to write that on here. This means multiply y values by 2, because that's what's up there. If that was a 4 up there, you multiply by 4. So now that's going to stretch and become 0, 4. That's going to become 2, 4. And is 40 still going to stay at 40?
Yep.
So when I take 0 times 2, it's still 0. But the rest of this has been stretched.
That was a really good graph, that last one.
Thanks.
Like, you were just like straight.
What about when the number's on the inside? What? Kind of weird, right? So this is definitely a horizontal because it's inside. And it's actually a horizontal stretch? No. Horizontal compression? You don't really have to know that, but if it's the opposite, it switches bigger than one is a compression. And it says replace x with a times x, but only do it with your x's. Because it's horizontal. Okay, hold on, don't do this yet. Multiply, okay, here, just kidding. Multiply by each x by 1 over a. That's how it's going. So instead of multiplying everything by 2, what are we going to multiply everything by? 1/2. A fourth. So we're compressing it by half, but it's a 2 in there. So we're going to take all of our x values and cut them in half. Ooh. So that would be times 1/2 on this one. Good catch, Nathan. Or divide by 2, that's another way to think about it. So -4, -2 is going to become -2, -2. 0, 2 is going to stay there because you can't divide, 0 divided by 2 is just 0. And then that becomes 1, 2. And 2, 0. So you see how we've taken that? Good catch, Nathan. If that was a 1/2 up there, then we would have doubled everything because you have to do 1 over that. The horizontal ones weird me out because they're the opposite of what you think. So what we've done is we've taken that graph and we've compressed it together and made it kind of squished. In algebra 2, we call that shrinking the graph. Those are the ones I think that can kind of trip you up sometimes, or maybe just because they trip me up sometimes. But other than that, it's just kind of moving them around. The only other thing on your homework today is they give you equations and graphs, and you just have to match up. If it's moved down 2, you find the one that has a -2 just to kind of practice with your transformation. But it's just like ABCD that you just match them up. You have to draw graphs for these, yes. So I'll give you graph pictures. A horizontal stretch would be if this said f of 1/2 x. Think about dividing by 1/2 means you would multiply by 2 because you have to flip it over. So that would take it and stretch it out. That would be, you would get -8, -2, like it would go out. Vertical compression. Yes. A vertical compression would be if there's a fraction out front here, that's going to take it and shrink it like this way. Does that make sense? Yes. And so that's why it's easily to confuse them because they're the exact opposite of each other of the rules on it. So that's where I say you don't have to memorize it. You just have to, this is the only thing on the test that requires that you have an idea of what to do on it is stuff like this. Okay, so your homework, which I'm giving you the rest of the time to do, is 7 through 18 all. Those are matching. No work to show on those. The annoying part is it goes from one page to the next, so you have to kind of flip back and forth. But I believe 1, 2, 4 of them are, or no, 6 of them are squares and 6 of them are absolute values. So you just have to match You can do the long graph if you want. And then 64 is the one like this, where you have to actually graph what's happening. So 2, 4, 6.
7 or 6?
7. Well, let me find my graph paper.
Good eye.
There are 7 graphs on 64, but you could like double up and do more, like 2 on 1, right?
Yeah.
7. Oh, that's right. Because there's 8 through whatever. So you can do your matching ones on this too if you want, because you don't have to really show work for the graphing ones. So if you want to do your matching ones on this, then I'll have to sheet of paper on the damn graph. If you don't want my graph paper, just do that.
So you said what? Hold on. How did I say that?
7 through 18 here, there's matching, right?